In this episode of Cloud Performance Atlas, I help some toy makers with their boot times. Will performance be the hot toy this holiday season? Stay tuned to find out. Capital Fun is an IoT toy developer who has been converting over portions of their architecture to serverless systems. However, as their Google Cloud Functions usage didn't scale to meet demand as fast as they wanted, they quickly pinned cold boot time as the culprit and reached out to us to see how they could improve it, which totally makes sense. Even though GCF is considered a serverless architecture, you still have to be aware that there are some cold boot time overhead as new instances are spun up. Now, most of the time, your function will already be running an instance and will be ready to handle future triggers as fast as possible. However, your functions might be in a cold state because, number one, your function has been deployed but not triggered yet, or number two, your function has been idle long enough that it was recycled for resources, or number three, your function is auto-scaling to handle capacity and creating a new instance. In any of these cases, your code isn't currently running, and the next trigger event will spin up a new instance. Now, when it comes to GCF, the number one contributor to slow cold boot performance is dependencies. When a module boots, Node.js resolves all the require calls from the entry point using synchronous I/O, which can take a significant amount of time if the number of dependencies are large or if the content itself requires a lot of linking. So when I saw that their GCF module had 50 dependencies, well, we knew where to focus our efforts. As a first step, we worked with their tech team to trim out any dependencies that might not be needed. This includes areas where they might be using one function from a library, but including the entire library. So after a lot of negotiation, digging, and spaghetti code clinging, we were able to get down to 8 packages, resulting in a 2x performance in cold boot time, which was good, but there was still work to do. Next up, we looked at what dependency versions their functions were actually using. More popular versions of a package are most likely already stored in GCF's dependency cache, meaning that importing and resolving can be done much quicker. So once we unified all of Capital Fun's dependencies to use the same versions that were more likely to be used in the cache, we saw another nice performance boost. Finally, digging through the Node.js code, we decided to set up lazy loading of core requirements rather than having them all occur in cold boot phase. This allowed us to require only what's needed at the start and then switch to an async version of the require keyword later for specific request handling, bringing down the cold boot times even further. With these small changes, we saw a 10x improvement in Capital Fun's cold boot time, which isn't bad for a day's work. If you want to know more about the changes, check out the article in the description below, and don't forget to check out the rest of our Cloud Performance Atlas content, because when it comes to performance, every millisecond counts.